Hey everyone, in this video we're going to be wrapping up section 4.1 in your textbook, talking about some features of polynomial graphs and what we're going to call analyzing these polynomials. So this will incorporate several things that we've learned on like end behavior and the real zeros, whether a function is even or odd, looking at the leading coefficients and things like that. And so let's go ahead and look at what we're going to be asked to do. We're given a graph of a polynomial function, and we're asked to answer several questions. We're asked to find the degree of this polynomial, and not necessarily the degree, whether it's a third degree or fourth degree or fifth degree, but whether it is a even degree or an odd degree. We're also asked to determine if the leading coefficient is positive or negative, how many real zeros there are, and then we're going to be asked a series of questions about maybe some new stuff, and that is minimum values, that is relative minimum values, or relative maximum values, or just relative, we could say extreme values. So let's tackle these one by one. And again, this is sort of all encompassing of 4.1, what we can call analyzing a polynomial. Your book asks you to do these things and a couple other things, but this pretty well covers it. So when we analyze this, the first thing we're asked to do is determine if it is an even or odd. So if you remember back when we did end behavior, we had like these four options. We had if a function sort of looked like this, we would say that was an even power, and this was a positive leading coefficient. Even degree, positive leading coefficient. If something looked like this, it's also an even degree. So it could be like 2, 4, 6, 8, whatever. And this would be a negative leading coefficient. If we had something that looks sort of like this for the end behavior, well, then we said this was odd because the function goes opposite directions as we look at the end behavior. And this would be an odd positive. And then if it was the opposite way, sort of like this, and then this would be an odd because they're going opposite directions and negative. So we can determine all of this by looking at what's happening at these end behavior points. If it is even, you'll notice it always goes in the same direction. Odd, obviously, is opposite directions. Right? And then as far as the leading coefficient, notice in the positive one, if we look in the positive x direction, that would just be this. It's going up to positive infinity. And if it was negative, it goes down to negative infinity. This one is positive, and if we look at the positive one, it goes up to positive infinity, and this negative one goes down to negative infinity. So if we just look at that one point, or one end behavior, the positive x direction, that actually can tell us whether it is a positive or negative leading coefficient. And then if it is even, that means they're going in the same direction, and it's odd if they're going in opposite directions. So we can determine a lot about this function by just looking at the end behavior here, these two things. So given this function, let's go ahead and identify those. So notice those are going in the same direction, so that means it's got to be even. And then positive or negative, well, for that, all we really need to look at is just this. The positive x direction, is it going up to positive infinity or down to negative? And that is going to positive infinity. So we want to go ahead and change that to positive. And notice that matches the end behavior of this first one, even positive, right? But again, you should be able to actually do this without looking at your little chart. All right, next thing is real zeros. We've done this very recently. Real zeros are places where the graph either crosses or touches. Real zero is places where the graph, the function, not only crosses, but could be touches as well, crosses or touches the x-axis. Remember, if it touches, that means it was actually what we'd said a multiplicity of 2 or 4 as an even multiplicity. And if it crosses an odd multiplicity, meaning generally 1 or 3. So again, this is also called a repeated root where it touches but doesn't cross. So just some previous terms. So we're asked to find how many real zeros there are. Well, if we just count them, we got 1, 2, 3. 3 places where it either crosses or touches. So we're going to say 3 real zeros. Oh, sorry, I put that in the wrong spot. And last but not least is relative minimum. So when we talk about minimums and maximums, particularly relative means sort of in comparison to the surrounding points. So a relative min, you could think of this as like a sort of a little valley. So compared to the areas around it, it is lower. It's the lowest point in comparison to some measure of points around it. So if you just look for these valleys, you'll see there is a valley right here, and that this function goes down and down and down, and then it reaches the lowest point and then goes up. So it's a minimum compared to the points around it. It's not a absolute minimum. The absolute minimum would be the lowest point overall of this function, but it is a relative minimum comparison to the points around it. So it's a valley. And if we were to sort of track this function more, you'll see there's another relative minimum here, right? There's another little valley there. That one happens to be the absolute one as well because it's the lowest point, but it is a relative minimum. So at that point there's a minimum. This just continues to, it levels out a little bit, but then it just keeps going up. So there are 2 relative minimums right here and right here, where the function sort of dips down, it reaches the lowest point, and then starts to go back up. So in terms of the slope of this function, we would say it's decreasing, right? And then it goes to 0 ultimately, and then it goes back to increasing, right? So the slope is going down, 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 decreasing, and then it hits 0 at some point, and then it starts to go up, increasing. So that's how we can identify a relative minimum. If the slope is decreasing, then it eventually hits 0 and then goes up to increasing. That tells us there's a minimum. If you go on to calculus, we'll talk about these a lot more. And so if you're interested in that, there's a lot more in calculus than that, but you do talk about this in calculus. So on the contrary, a relative maximum would be sort of a hill. And in that case, we have an increasing function, which then gets up to a slope of 0, and then it starts decreasing. So in this case, if we were asked to find it, if we were to just sort of trace our function, we got a little hill right here, so that would be a relative max right there. Relative max. And then if we just continue to trace this, goes down, minimum. It looks like there might be one here, but it doesn't actually ever sort of switch. So it just continues just to go up. So that's neither a minimum or a maximum right there. So it'd be neither. So there would be one relative max, and then relative mins on this function would be here and here. So there's a lot going on in this function, a lot of stuff we're figuring out. Most of it is review, but these relative mins and maxes are maybe new terms, maybe not. Maybe you've seen this before. All right, so as asked, how many relative minimums? So there was 2 relative minimums. And some questions, in different assignments, you might be asked, well, where are the relative minimums? So you would say, the relative minimum is at this point, x equals -5, and the value is 0 or whatever. So there's a relative minimum at -5, 0. That's what you could say. We're just asked to identify how many. We'll go with that. All right, let's go ahead and look at another one. I'll keep some of this stuff on here. So first thing we want to do is identify the degree, if it's even or odd. Just remember, even, the odd part went away, is odd is different direction, opposite direction. So even means that the end behavior goes same direction, which both of these are going down to -infinity. So this would be an even degree because they're both going down. And then we look specifically at the positive one here to determine if the leading coefficient is negative or positive. Since it is going down to negative infinity, we would say that the leading coefficient is in fact negative. Next up is to identify how many real zeros there are. We've got 1 cross, 2, 3, 4, 5, 6. 6 places where this thing crosses 0. So type that in. All right, and then we're asked to find relative maximums on this. So relative max, it's like that kind of got taken away there. Relative max are the hills. Where are the little hills? So there's a little hill here that goes from increasing up to 0 and then goes down to decreasing. There's another hill at the top here, so that'd be 2, and then another hill here. So there would be 3 relative maximums. If we were asked to find the number of relative minimums, those would be 1 here is a valley, another valley, so there'd be 2 minimums and 3 maximums. All right, let's go look at maybe 1 or 2 more. So first of all, even or odd. Notice in this one, they're going opposite directions, the end behavior is, so that tells us it's odd. We then look at the positive x1 to determine the leading coefficient. Since it goes down to negative infinity, that tells us our leading coefficient is also then negative as well. Number of real zeros. We've got one where it touches here. It's kind of hard to tell on that one, but it looks like it does touch there. And we've got another one here, so that's 2, 3, 4. So 4 real zeros. And then we're asked to find relative minimums. How many relative mins do we have? Those are the valleys. This is a relative minimum here. It goes from decreasing to 0, then increasing. And it looks like another minimum down there. And that would be it. So there's 2 relative minimums. All right, let's look for one more. And I think there are some problems where ask you total number of extreme values or something like that. So I want to try to find one of those. No. There we go. Okay. So this one asks us relative extreme values. So when you see this term relative extreme values, that's both relative mins and maxes. In calculus, something you might call these a relative extrema. So they're referred to sometimes, relative extrema, or the extreme values. Okay, so let's go ahead and tackle this one. First thing would be looking at the end behaviors. They're going opposite directions, which makes it odd. The leading coefficient, we look at the positive one here. It's going down to negative infinity, which makes the leading coefficient negative. There are a total of 1, 2, 3 real zeros and relative extreme values. Okay, so we want to circle all the mins and all the maxes. If we were to just trace this function, the first extreme value we're going to get is actually here. There's a relative minimum somewhere in there. The first place there where it crosses is not an extrema because it never changes from decreasing to increasing. So there's one relative min. There's a relative max up here, and that's actually it. There's no more mins or maxes. So there's a total of 2 relative extreme values. All right, good luck with that. Just a reminder, there is always the help videos, which you could watch those, give you a different perspective as well. And as always, reach out to me if you need help.